Hi, welcome. In this video, we will solve problem coin change asked by companies like Amazon, Microsoft, Oracle, LinkedIn, and many others. Now let's check out this problem coin change. And it is the most important problem on entire DB series. I am saying that because this is the only problem that is asked in so many interviews, so many companies. Adobe, Amazon, Google, Microsoft, Samsung, right? Different companies they have asked. Apple, right? And now this problem becomes the saturation problem. That means even if you are cracking a lower package companies, 6 LPA, 5 LPA, you might get this type of problem because this is so famous. Okay. So let's try check it out this problem. So you are given an integers array coins representing coins of different denominations, an integer amount representing the total amount of money. So we have this amount, total amount, and different coins of different denominations. Okay, return the fewest number of coins that you need to make up the amount. So I just want minimum number of coins to make this amount. Okay, if the amount of money cannot be made by any combination, then you need to -1. You may assume that you have infinite number of each kind of coins. So basically, for each coin, right, for 1, 2, 5, these are not limited to 3. You have an infinite number, right? So if you want to take as you can take as many as coins of 5, you can take as many as coins of 2, as many as coins of 1 to make this 11. So now let's check out this some sample input and outputs. So to make it 11, right, how many coins, minimum coins I will be required? So see, I will be required 2 coins of 5 that will make 10 and 1 coin of 1 that will make 1 and the total will be 11. That's why the total coins needed that is 3, right? And here the input coins we have 2 and I need to make an amount 3. So by 2 I can make 2 amount, I can make 4, 6, 8, right, in this fashion. But I can't, I will never be make an amount of 3 by number of 2 coins. Okay, so that's why I will return the output as -1. Okay. Now suppose you have 1 coin and you need to make an amount 0. So 0, that means you don't need any coin, right? The output will be 0. That means you are not taking any coin. So then the output will be 0. Now let's see how we can solve this problem. So I want to make an amount that is given 11, right? And I have different coins like, let me say, I have coins 1, 2, and 5. So what is your approach? Like, what is the first brute force approach that comes to your mind? That you will try all the possibilities, right? So what will be the possibilities? Basically, you can start from 1, right? And you try to create an amount of up to 11, right? So you will take 1, 1, 1, and so on till 11 times to make the amount 11, right? That is one way. Then you will try to make a different combination that you will take 2, or like here you will take again, you will continue this series, right? And here you will take 2, right? And then you will make an amount of 11. And suppose then again you will continue with this series and then you will take again 1, 2, right? Then you will make this up, right? So if you are going with this brute force approach, you need to find out, like, there are lots of possible ways to create an amount of 11, right? And that will take as much time for a smaller problem, right? So we need to think a bit smarter, right? We need to come up with an approach that will be an smarter. So what can your approach can be, right? If you are thinking that let's try to sort it. So basically what you will do, you will sort it in descending order, right? So if you sort it in descending order, your coins will be 5, 2, and 1. And now there are less possibilities. There will be less number functions that you will go through and you can easily get it. Like, so basically you need 2 coins of 5, 1 coins of 1, and you will make it 11. But here is one catch, right? That is not entirely true for all the cases. Why? So let's take one scenario that you have coins 8, 1 coin is 6, 1 coin is 5, 1 coin is 2, and 1, right? If I sort my entire coins, right, my array will look like this: 8, 6, 5, 2, 1, right? This will be my sorted coins. and the amount is again, let's say the same amount is 11, right? So if you are solving with this, how you will solve it? You have an 11 as an amount. You will first take the higher number, then you will take 8. So 11 minus 8 is 3, right? So now you pick 8 again. Now you can't pick 6. Now you can't pick 5. You can pick 2. So you will take 3 minus 2. There will be 1. Now you can take 2 as well. And then 1 minus 1, that will be a 0. So you will take 1 8 coin, 8 value of coin, then 2 value of coin, and then 1. Then total coins required, there will be 3. But the same amount 11 can be done by 6 and 5, right? One coin of 6 and one coin of 5 you can make 11. So if you are thinking that you will go with the greedy approach, right? That means you will sort it and you will first go with the higher coins, okay? That means higher value coins, higher denominations coin will give you the minimum coins, right? So that will be a wrong approach, right? Higher denominations coins will not give the minimum coins. Give the minimum points in all cases. Okay. So this is one note point. Okay. Now let's understand how we can solve this problem. So from the failure of this thing, we are getting some insights, right? And remember, that's what the Einstein Thomas Alva Edison theory is like. The failure attempts will gives an observations, right? And here also by this failed experiment, right? We almost failed here because we figured out that higher denominations coins will not give the minimum coins. Now, which will give the minimum coins then? So basically, I just need to figure out that when I'm subtracting 8 from 11, I am getting 3, right? And then I'm looking for 3, right? Can this be possible that I will simply check for how many coins is needed for a certain amount? So basically, I want to make 11 as an amount. And if I'm subtracting, suppose 11 minus 6, right? Then I have a remainder as 5. Now I'm checking for how can I make 5, right? Then I am again checking it. So is there any way that if I can store some that, like for to make a 5 rupees, to make a amount 5, to make an amount 5, this will be the minimum coins. So basically I want to store, if I am having an amount of 5, how many minimum coins will be required? If I am storing this thing somewhere, then it will be very easy for me to calculate the same number of coins for 11. See, right? Suppose let's take an case of 5, that you have an amount of 5 and you want to find the minimum number of coins needed for 5. And if you are checking seriously, like from 1, 2, 3, 4, 5, and suppose you are taking a note to make minimum number of coins to make 1, minimum number of coins to make 2, minimum number of coins to make 3, minimum number of coins to make 4, that's 110% true that your answer to make 5 with minimum number of coins will be true. Because for the entire cases, for the entire 1, 2, 3, 4, you are taking the minimum number of coins needed. Are you getting this approach? Are you getting a hunch how I am going? So basically, it is not about higher denomination. It's about the amount that you are making. The lesser amounts, that means if you are making an amount of 5, the lesser amount should be with the minimum number of coins. If they are with the minimum number of coins, your result will also have the minimum number of coins. Okay, let's see. Let's understand this is an example. Now, this problem you can solve with, if you have solved recursion, right? If you have solved recursion, you can apply same method by a recursion. Basically, suppose you have an amount 11, and what are the number of ways? If I am taking this case 1 to 5, how many number of ways that you can make this 0? So basically, you need to start from 11 to go till 0. Okay, and what are the different ways available? So either you can take a way of 1, right? That means if you subtract 1 coin, either you can subtract 2 coin, or either you can subtract 5 coins, right? 5 rupees denomination. If you are subtracting 11, then what will be the new amount? That will be 10, right? And then if you are subtracting 2, then it will be 9, then it will be 6, right? Now the same problem you can see. The bigger problem, the bigger problem is converted into a smaller problem of the itself. Now my task is not 11. Now my task is amount 10. How I can make an amount 10? By the same different paths. So again, 1, then I can go with 2, then I can go with 5, right? So if I'm taking 1, I will take my icon will become 9. If I'm taking 2, it will become 8. If I'm taking 5, it will become 5. Again, my same problem is converted to a smaller problem. Now same problem is converted into a smaller problem. Again, I will solve for 9. Again, I have three choices. Either I can take 1 path, 2 path, and 5 path, right? And again, this amount will become 8, right? This amount will become 7, I guess. And this amount will become 2. Sorry, not 2. 9 minus 4, it will become 9 minus 5, it will become 4. Now see, like we will continue this, right? This will continue. And the only thing that we need to keep this mind, whenever we are getting an amount of 9, whenever we are getting here the amount of 9, here we are getting 8, right? We need to take the minimum ones, right? So here, this path, maybe if I go continue, then this path will give total number of, for 9, to make a 9, total number of coins will be needed 9 coins. Here you will get maybe 8 coins. So you need to check like all the paths, and you need to take the minimum of the path, and that minimum you need to store in the DP. Okay. Basically, by this way, you can also solve this problem, right? So the next, so the next thing here that we need to basically understand is brute force approach, not brute force, sorry, the base case, right? So what will be the base case? Right? So basically we need to check, right? If I am continuously decreasing from here, like from here 8, it will become 7 again and again. So if I am reaching to 0, right? If my amount is getting 0, so that is the one possible path. So I will return 1, right? So that is the one possible path. If my amount is getting -1, right? I am getting a negative value, right? If my amount is getting less than 0. So what I will do, that is not a possible path, right? That is not a possible. Remember the climb states problem, exactly same. So I will say return -1. That is not a possible path, right? So by this case, right, by taking these base case, you can solve this problem by taking recursion and using DP as memoization, right? So we have one more approach to solve this problem, that is the bottom up approach. Okay. So we will try to solve by the bottom up approach. We will use the DP here as well, right? Now let's see. So I will take my same examples that I have read earlier. So basically I want to create an amount 11. Okay. And what will the total number of coins that I have? So basically I have 5 coins, 1, then 2, then 5, then 6, and then 8, right? So these are the total coins that I have, and I want to make an amount of 11. So what I will do, again the same strategy. The strategy will be that for all the amounts that is starting from 0 to 11, I will try to find the minimum number of coins needed to make all these between amounts. If I am going with the minimum path, I will surely make an minimum number of coins for 11 as well, right? So that is our intuition, right? So now let's create a table for better understanding. So let me quickly create a table. So now let's see, here is the table, and I want to make all the amounts. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11, right? And now let's see, now let's start. Okay. And this array should not be sorted, right? It can be any order. Basically you are taking coin, and if the value is getting less than of it, so I won't take the coin. Okay. So let's see, to make an amount of 0, how many coins will be needed? Basically I don't want any coin to make an amount 0, so that will be 0 here. Okay. Now to make a coin, to make an amount 1, so what I will do, I will try with all the different coins available, right? So I will try it out with 1. So if I am taking 1, so basically my amount is, let me write the amount. Right now the amount is 1, right? And if I'm taking one coin, so it will be 1 minus 1, 0. So yes, I'm getting 0 by taking this coin. So how many coins I needed? Only one coin, right? Now, similarly, in the next case, I need to make an amount 2. For 2, I will take again start from 1, right? And how I will make 2 minus 1, 1. And I will check for 1 how many amounts I just need to take. Need to take one amount. So one, this one coin, this, and one coin for this one, because I am taking one coin here. So this one and this one will make two, right? So again, let's try out different possibilities, right? So what I will do here, I will check. This is for coin one, right? If I am taking coin one, right? So 2 minus 1 will give me 1. And from here, I am getting 1. That means for to make 1, I want only one number of coins. So basically, see, I got a coin 1. I subtracted, I am getting a value of 1. And I know to make an amount of 1, I need only 1 coins. So this one plus this one will tell me that I will be requiring 2 coins. Okay. So this is done by 1. I will check for coin 2. Right. I will check with coin 2. And for 2, 2 minus 2, it is giving me 0. So here I will be required only 1, right? Then I will check for 5, but by taking 5, right? So if I'm doing 2 minus 5, it will give me 0 or minus 3, not 0 as well. Minus 3. That means 5 is greater basically, right? So I can't take 5, I can't take 6, I can't take 8, right? So here the two options I have, that either I can go with the 2, either or I can go with 1, right? So for to make an amount 2, I will be requiring 2 coins and I will be requiring 1 coins. So I will take the minimum and I will update with 1 here, right? Let me use the red pen here only. So I will take 1, right? Similarly, I will next case will be for 3. So now let me erase all this thing. And now let's check for 3. So I need to make an amount 3, right? I will again start with 1. So if I am starting with 1, again let's take 1 coin. So again, if I am starting with 1, 3 minus 1 will give me 2. And to make an amount of 2, I know there is only 1 coin required, right? So 1 for making 2 and 1 coin for amount 2. So total coins will be required, that is 2 if I'm taking 1. Now let's check for with 2. So if I'm taking second number coins, 2 denomination coin. So I will do 3 minus 2, 1. And I know to make an amount of 1, I will be requiring 1, right? So this one and this one, right? 1 coin to make a 2, to make a 1, and 1 coin for an amount of 1. So I will be requiring 2 coins. So here both, by taking both the things, I am getting only 2. Let's check for 5. But 5 is greater than 3, so I can't make it. 6 is greater, 8 is greater. So here I will take the minimum, both are equal. So the answer will be 2 only. So I will update with 2, right? The next thing. So let's see here. Now my amount will be 4, right? So to make an amount of 4, again I will start from taking 1, right? So if I'm taking 1, right? So 4 minus 1 will give me 1, sorry, 3, right? So now I will check to make a 3 amount, how many coins required? 2 coins required. So 2 coins required to make an 3 and 1 coin to make 3, basically here 4 minus 1. So in total 3 coins will be required. Okay. Now I will check to the next one, coin 2, right? So if I'm doing 4 minus 2, I will get 2 to make 2. I want only 1 coin. So 1 coin here and 1 coin to make 2. So 1 plus 1, 2 coins. So again, I will take the minimum of it. So 3 and 2, which is minimum? 2. So I will put 2 here, right? Now what I will do, again, I will go with the next amount. Now the amount will be 5. So I will solve for 5. So if I am solving for 5, what will be my answer, right? If I'm taking coin number 1, coin denomination 1. So 5 minus 1 will give me 4. And for 4, I want 2 coins. So 2 plus 1 coin, that is 3 coins I will be needed. Okay. Now let's see if I'm starting with 2. So if I'm starting with 2, so 5 minus 2, I will get 3. And to make 3, I want 2 coins. So 2 coins to make 3 and 1 coins to subtract. So total 3 here as well. Then I will check 5. Can I take 5? Yes, that is equal. You can take 5. So I will check for 5. So for 5, 5 minus 5 will giving me 0. That means only 1 coin needed here. So from these three values, 3, 3 and 1, my answer for this will be 1. Right. Similarly, I will check for 6. So let me quickly delete this. Right. I will check for 6. So for 6, again, I will start from here. Right. So if I'm starting from here, 6 minus 1 will give me 5. To make 5, I want only 1 coin. So 1 plus 1, 2. Right. Now I will check for again with the 2 coin. Right. I will check for this. So 6 minus 2 will give me 4. And for 4, I want 2 coins. So 2 coins here, 1 coin here. That will make 3. Right. And if I am starting with 5, so 6 minus 5 will give me 1. To make 1, I want 1 coin. So 1 plus 1 will give me 2. And I can take 6 as well, right? I can take 6 as well. So 6 minus 6 will give me 0. So only 1 coin will be required. So again, I will take the minimum 2, 3, 2, 1. I will take the minimum, which is minimum 1. So I will update with 1. Similarly, if I check with 7, 8, 9, 10, I will get the results. So let's quickly fill it. So for 7, if an amount of 7, I will start with 7 minus 1. It will be 6. For 6, I want only 1 coin. So 1 plus 1, it will be 2. For 7 is starting with 2, it will give me 5. To make 5, I want 1 coin. So 1 plus 1 again 2. For starting with 5, so 7 minus 5 will give me 2. To make 2, I want 1 coin. So 1 plus 1 again 2. For to start with 6, 7 minus 6 will give me 1. To make 1, I want 1 coin. So 1 plus 1, 2. So from all these variations, I am getting 2 coins only. So that's why the answer will be 2 here. Okay. Now let's check for 8. So for 8, here, how many coins I will be requiring? So 8 minus 1 will give me 7, right? And to 7, I want 2 coins. So 2 plus 1 will give me 3. If I want to make 8 with 2, right? So 8 minus 2 will give me 6. To make 6, I want 1 coin. So 1 plus 1, it will be 2, right? And here, if I am taking 5 coins, so 8 minus 5 will give me 3. To make 3, I want 2 coins. So 2 plus 1 will give me 3. If I am taking 6, it will be 8 minus 6 and it will give me 2. So here for 2 making, I want only 1 coin. So 1 plus 1, 2. And I can take this 8 as well, right? So 8 minus 8 will give me 0. So that means 1 coin will be required. So again, I will take the minimum 1, 2, 3, 2, 1, which is minimum 1. So I will update with 1, right? And similarly, I will fill all these table, right? So let me fill 9 and 10 and I will solve 11 in front of you. So I have filled 9 and 10. So basically for making 9, I want 2 coins. For 10, I want 2 coins. Let's check for 11. So now the amount is 11. Okay. And to make an 11 amount, again, I will check with coin that is starting from 1. So I will check from 1, right? If I am starting from 1, 11 minus 1, 10. And to make 10, I want 2 coins. So 2 coins plus this one, total 3 coins will be required if I am taking 1 coin here. Then if I am taking starting with 2, so 11 minus 2 will give me 9. And to make 9, I want 2 coins. So 2 plus 1, it will be again 3, right? So now I will take 5 and I will check 11 minus 5 will give me 6. And to make 6, I want 1 coin. So 1 plus 1, this will give me 2, right? Now I will check with 6. 11 minus 6 will give me 5. And to make 5, I want 1 coin. So 1 plus 1 will be 2. Now I will check with 8. 11 minus 8 will give me 3. And to make 3, I want 2 coins. So 2 plus 1, that will be 3. So from these answers, 3, 2, 2, 3, and 3, the minimum coins that will be required for here, that will be 2, right? So my answer will be 2 here. That is, you take this either 5 and 6 and 6 and 5, right? That's why the answer for this problem, that is amount 11, that will be 2. And you can simply return this DP of last 11, and that will be your answer, right? So basically, this is the approach that we will use. Okay. And in the next video, I will give you a code implementation of it, right? How you can apply this code. Basically, what we are doing, if you are simply writing some few steps. So basically, I want to check for each amount. So I will start my amount. You can take an iteration that will start from 0 till 11, right? One iteration, one loop. Okay. Then you can take the next iteration on the coins. Okay. And now what you need to do, you need to simply subtract each iteration, each your amount, right? Each amount by your coins, right? First of all, if you are getting a negative, that means you don't need to take. If you are getting a positive, then you would to simply find in your DP, in your this array stored. Okay. And then you need to take the minimum of it. Okay. So basically, this is how you need to solve it. I hope the approach is pretty clear to you. In the next video, I will give you the implementation of it. And in after this, we will do a bit of dry run. We have already run, but we will check